Hello, and welcome to today's webcast on asset management, brought to you by Plant Services and Emerson Process Management. I'm Thomas Welk, Chief Editor of Plant Services, and I appreciate your joining us today. This webcast is sponsored by Emerson Process Management and Emerson Business. Emerson Process Management is a leader in helping businesses automate their production, processing, and distribution in the chemical, oil and gas, refining, pulp and paper, power, water and wastewater treatment, mining and metals, food and beverage, life sciences, and other industries. The company combines superior products and technology with industry-specific engineering, consulting, project management, and maintenance services. And now I'd like to introduce our speaker, Brian Overton, who will present Not Your Granddad Machinery Protection System. Brian supervises machine health monitoring systems training in Emerson Process Management, training services representatives and world area personnel on the installation, configuration, and commissioning of continuous vibration monitoring systems. He also delivers operations and maintenance training for Emerson Process Management customers. Welcome, Brian, and thanks for presenting today.
Thank you, Tom, and welcome everyone to the webinar. I do appreciate the time you're taking to attend this. I know we all have busy schedules, and so we'll look forward to presenting useful information that you will find that may help you as you continue to grow your reliability programs. So getting started here, Not Your Granddad's Machinery Protection System is kind of a unique name for our webinar, but as we go through the material, you'll see what we mean by that, and I think the title will become a little more apparent to you. But before we get started with the material, I'd like to take just a quick poll. Is your protection system capable of being more than a shutdown switch? If so, do you use it in that way? So if you would just take just a few minutes to click on the associated radio button that best answers the way that your present system uses a protection system that you may have at your facility, that would be greatly appreciated. And then we'll take a look at the results in just a brief moment here and kind of get an idea of where everyone is at. Okay. And then basically, as each of you are answering this, we're getting live data, and so as soon as we get done with this, since it is a required question, then we'll continue to move forward with the material that we're presenting today. Okay. Just waiting just a little bit longer. We've got a little over half of you have responded. Okay. More coming in. So as you can see right now, just looking at it, we still have a few more left to respond. But you can see that we've got 38% so far. At least 5 people have responded. No, their system is not capable of being more than a shutdown switch, or know that they're using it and they're not using that in that way, but they would like to. Then we also have a couple others here. Yes, we have embedded protection, and no, we don't care, are tied at 23% there. So you guys are able to see some of the results. Okay. Let's go ahead and we'll move forward. Make sure you guys can see where we are so far. Okay. So with 79% of the people responding, as I said, you can tell that 40% are almost half of it, at least in the who has responded there, says that they're not using it in that particular method, but they'd like to. So what we want to focus on here is what does the next generation of protection systems look like, and how is it different from what your granddad had or back in the 20, 30 years ago? Where has things progressed? How has it changed? How has it improved and enhanced from then until now. So that's going to be the focus of the presentation. So if we take a look at protection systems in general, we looked at protection systems. Basically, they're there to protect your asset. Okay, so whether it's a turbine or whether it's a boiler feed pump or an ID fan or some of these very critical pieces of equipment in the different plants, they need to have a means of shutting down that system whenever there is an adverse condition that is detected, generally a high vibration condition, or in some cases maybe even a shaft position issue, so that you don't cause a lot of secondary damage to other components, or even possibly causing issues that would affect the safety of personnel nearby. So the key things you have to look at is that one is the condition is pre-configured. So you kind of have to have an idea of what kind of condition it is you're going to be looking for, so that you can set that trip set point. And that trip is determined by the amplitude of that particular parameter that you're monitoring. So you kind of, again, have to have that pre-knowledge of what kind of failure modes can we expect from this asset, and at what level should we set the trip so that it helps prevent any kind of catastrophic damage or extensive damage to the assets, to the plant, to people, and then of course all of that's going to add into your financial impact for the plant itself. The other thing is that if you have the knowledge to set the trip points, or if you don't have that knowledge, then you can always look at the OEM for recommended settings. They will generally have an average set point that can be used through their testing, and of course recognizing that things are going to be different based on the installation, and you're going to have above average and below average equipment, so that set point may or may not be where you really need to be, but it is a good place to start. Okay, and so you want to get that set point so that you can protect the assets. The key thing that protection systems have proven their effectiveness over time. Their value is there. It's like, okay, we can shut it down and we can help protect the assets. But the question is, wouldn't you want to know even before it trips? Yes, the trip provides a protection, but wouldn't you want to know that, hey, I've got a problem that is developing, and I would like to know before it gets to that trip point? And those of you that have used online protection systems, or even like we've talked about a little bit, the shutdown switch or the earthquake switch on some of the old equipment, basically that just trips and shuts you down, and you really don't know why. Now you've got to investigate and figure out what was the root cause of that trip besides just high vibration. So in the words of Art Crawford, one of the fathers of the vibration industry, he always asked the question, wouldn't you want to know why? Okay, don't you want to know why it tripped instead of, hey, it tripped, now I've got to restart it, or and trying to figure out, can I restart it? So you need some data right away in order to make a very educated decision about continuing operation. So is it possible for a protection system to be more than just an earthquake switch? Okay, is it more than just a shutdown system, so that you get this data, you get this information? So the answer to that question is absolutely, yes, it is. Okay, the next generation of machinery protection is here, and it has features that have never been seen before in a protection system. So, and we're going to get into what some of those are, but first we want to kind of tie this into a timeline. Okay, so basically, if you look at the timeline here of some of the protection systems that are out there, basically you had back in the 1970s, you had the earthquake switches, you had other types of systems, and then basically you can see how the systems have progressed and moved through the time here over the several 40 years here that we're looking at. Okay, until we have the new generation of the protection system that's available today. So this kind of gives you some idea. The biggest thing is just that it was simply a shutdown system. And so this applies to any of the protection systems that are on the market, is that once you trigger or you exceed that trip set point, then it will shut down your asset. And so that's the key point. And most of the time, you don't have any idea as to why that happened. And so the focus behind all of this is really reliability of the plant. Okay, we want to make the plants much more reliable. So let's kind of tie this all into reliability, and then we'll come back and we'll talk about these features that that some of these features that you haven't heard of or seen before in a protection system. So reliability matters. Basically, if you have a reliable plant, reliability also improves your safety, and it also improves your availability, which in bottom line, it also improves your profitability. And that's what we're all really working toward in industry. We want to make sure that our plant is up and available when we need it to be. We want to make sure that our personnel are safe so that whatever actions they're taking, we have high regards for safety. We have safety programs that are out there to help make sure that the environment is safe for them to work in. We have OSHA. We have all kinds of other requirements. But bottom line, from the business standpoint, they also want to be profitable. And so a reliable plant makes all of this much more available, much more accessible. Excuse me. So when you look at it from a safety standpoint, machinery protection equals plant safety. And a typical refining facility will spend less than 10% of its time in transient operations. So this is when they're going to be shut down doing some work and what have you. It's going to be transient operations. But if you'll notice, 50% of all process safety incidents occur during this time. So 10% of its time is spent in this period, but 50% of the incidents occur during that time period. So if you're more reliable and you know more about what is happening in your plant and you know exactly what work needs to be done, you can do a better and more effective job of planning the work and then making sure that all the necessary safety barriers, all the necessary safety equipment and everything is ready, and also that your people are a little bit more aware of what's going to be done so that you can help minimize the accidents that occur during that time frame. Your asset availability, basically your protection system is really monitoring that system for any kind of changes. But here you have your availability here. Each year, 5% production of capacity is lost. Okay, and so you want to make sure that you're able to make sure that the system is up and running and available as much as possible. So 43% of your downtime, basically, let me just check for a second here. 43% of your downtime is unplanned downtime caused by equipment failure. Okay, and so you want to make sure that you're aware of what's happening before it just fails and unexpectedly. So basically, you're going to wind up with a protection system that has built-in predictive insights so that you'll be able to tell a little bit more information about what issues are developing over time. And then you also have a high availability with a high mean times between failure rate. You've got the modules that are monitoring your data, what have you. So this is all increases your production, increases your availability, and helps in the end to improve that bottom line. And so again here, this particular, the new generation of online protection system is API 670 compliant. Okay, and so we, API 670 has certain guidelines that need to be adhered to for certain situations, certain scenarios. And so you can see that there's better than a 100 millisecond response time to an event that occurs. There are redundant communications so that if one communication card fails, the other will take over the communication process. There's shutdown logic so that, again, we do provide protection so that we do shut down the asset if an unwanted condition exists, redundant power supplies, Modbus communication, all of your circuit boards, all of the modules themselves are conformally coded so that harsh environments will have minimal impact on them. Channel isolation, again, is a big one that's required by API 670, is to make sure that if one channel fails or something impacts one channel, it doesn't affect others. And then there's also buffered outputs so that you can still go to the protection system with your portable walk-around analyzers and collect data from that particular system if you wanted to collect some additional data. So buffered outputs are available there, or if you want to take the buffered outputs into another system, those buffered outputs are available for that as well. Okay. Your profits, basically a reliable plant increases your profit numbers. And then these numbers are going to vary by asset across a plant, so you have to look at each asset individually. You also have to look at the business units and what have you. Excuse me. And then critical and highly important assets are going to be the largest sources of profit loss. Okay, so look at a power plant. You've got a steam turbine, or at least you have a main turbine. It could be it could be a steam plant, it could be a coal plant, or so basically any of these. But you still have that main turbine. So redundancy, inventory, downtime, lost production, all of that are things that could be minimized here. In many cases, you have redundancy because you don't know when it's going to fail. One of them's going to fail. When it does, you put another one into operation so that you can keep running. But if you knew what was happening with each of those assets, then would you necessarily have to maintain that redundancy? That would be a business decision that each site would have to make, but definitely that's something that you would have to give you something to think about and consider. Then also your inventory, how much inventory you have to maintain to put into operation when something does fail, especially if you're using a run-to-failure maintenance mode. So you want to try and minimize inventory. Probably at least from the manufacturing side, a lot of people are looking at just-in-time shipping, so they don't maintain a large inventory of product. So they've got to be able to produce that product whenever they need to produce it so that they can ship it. Downtime has a huge impact, and then your lost production. Whenever you're down, obviously you're not able to produce, and so that production really hits hard in many different areas. The other thing is, again, if you're running to failure, you're in a firefighting mode, and you don't really know how the plant is operating. You don't really know the status of the assets in the plant. And so you want to make sure that you get all of this information. And so again, by improving the reliability of your plant, you will improve your profitability because you're going to minimize all of these different things here, especially your inventory, your downtime, and the firefighting that has to be done. I guarantee as shareholders will greatly appreciate that. So when you get to continuous operation, again, profitability is going to improve. Your predictive insights give you information into developing problems so that you can do analytics that are going to be intuitive. You can see what's going on. You have analytics that allow outage and risk mitigation planning. So the more information, the more data that you have, the better you're going to be able to assess a risk value to continuing to operate in that state of operation. Okay, so there's a lot of different things that go into that. Analytics to reduce your inventory. So now you've got information that you can look at to determine that, hey, I can reduce the amount of inventory I've got on my shelves because now I know ahead of time before it fails that something is developing. And it gives me enough lead time to get the part on order, get the part in-house, and have it ready to go for whenever we have our outage or our turnaround. And then so you're able to maximize any uptime. more reliable plant, you're going to be able to minimize any of these unexpected, unplanned downtime. So then overall, from a profitability standpoint, the ownership, the total cost of ownership gets lowered. So the electronic last-minute card configuration minimizes wiring and design challenges. You got easy configuration wizards that walk you through the steps of getting things set up and configured. You have less spares that you have to manage, and we'll talk a little bit about that here in just a minute with some of the features that we're talking about. And then there's no barriers due to safety ratings. Basically, because the future protection, the next generation protection system is classified to be in these safety rated areas, so that you no longer have to have barriers to allow passage of the signal from that safety area to the outside area. So here's some questions for you. What if your protection system contained the following? What if it had the ability to provide you with the prediction information as we have been talking about and making your plant more reliable? What if it had early warning tools, and if it had analytical tools that could be used? What if your I/O was flexible? Right now, most of your protection systems that are available, they're designed with modules that have very specific applications, so you have to maintain multiple modules in your inventory because you don't know which one's going to fail. You need at least one spare for each module. You need spare sensors. You need all these other things. So what if your I/O was flexible enough so that you had one module that could do pretty much all of your measurements regardless of the type of measurement? And so now you've reduced your spares as well as you have more flexibility. What about mobile applications? What about getting data to your smartphone or to your tablet? So what about having open communications to the system so that it's easy to pull data from the protection system into your HMIs or into your PI system, into whatever system that can speak Modbus and OPC UA. So it's real simple, real easy to get that data. Basically, your system is set it and forget it. You're able to configure it, set your alarm limits, and then you can pretty much walk away from it. You don't have to keep worrying about it. Easy to install and maintain. Cards are conformally coded, as we talked about before. And then also this all works with roller element bearing machines as well as with sleeve bearing machines. So a lot of your protection systems do not have many of these features that we've just mentioned here. So your asset availability, with the built-in predictive insights, one of the things that the data that you get with this is you can get waveform, you can get spectral data, and you can also get trend data so that you're able to monitor it over a period of time. What is happening? You've got spectrum information so that you can look at what type of issues may be developing. If it's a sleeve bearing machine, or you seeing some wear on the sleeve bearing itself. If it's a roller element machine, are you seeing any of the roller bearing defect frequencies showing up? Is it, and depending on what type of machine it is, what about misalignment? What about looseness? All of these things will be readily apparent by using the predictability features that have been embedded into the protection system. So you also can do your coast down and startup. You can look at that data as you pass through your criticals and see how the system is responding. You also have Bodie plots that you're able to pull up, speed and time. So all of this is available with the protection system, and it is embedded in the protection system. So effectively, by providing a protection and a prediction system together, one might expect to pay twice the price, but that's not the case. You buy a protection system, the prediction is embedded, it comes with it, And so effectively you've got a protection system that gives you much more than what the old generations of protection systems have provided throughout the years. You also have the early impact detection for roller element bearings. Okay, no other system has this capability. And so basically you get a single value that an analyst can interpret. He can take a look at it, and he can compare it to some rules that have been created to kind of give him an idea of how bad it's bad or is it good. So there's like a rule of tens that they can apply to different machine types to determine is there an issue. And this basically gives you an earlier warning than any other technology. This has been used very successfully with applications such as gearboxes, gear meshing, and also the roller element bearings. It has proven itself over many years. And then it also gives you an idea of the fault and severity of the issue as it is developing. It is very trendable, so it's something that can be trended over time, and until it's such a time as that it needs to be taken out of service and then repaired. So all of this is included in this next generation of protection systems. And we mentioned earlier about the fact that flexible I/O. So with this particular system, you've got a universal measurement card. And that universal measurement card, with the exception of temperature and process, basically all of your measurements are taken into that. It is taken into a universal measurement card. It doesn't matter if it is an eddy current sensor, an accelerometer, or a speed sensor. It doesn't matter what kind of sensor it is. You can take it into a universal measurement card, and then basically you configure that card to tell the card what type of signal is coming in. And so you can also mix and match your signals. So one channel could be an eddy current sensor, the other channel could be an accelerometer. And so that gives a lot of flexibility to your I/O now. And so it's no longer a dedicated module just to specific types of measurements, so that you now have the ability to use each channel in your system instead of having to skip channels because, well, that particular channel can't measure this type of sensor. There is the temperature and process card, so that any of your temperature readings, RTDs, thermocouples, and also any of your process data that you bring in up to anything from the range of minus 10 volts to plus 10 volts. So basically those would go into a temp process card. All of these fit into the same rack. There is no different rack. These measurements can be in the one rack. Each rack can hold up to 11 modules. And so that's measurement modules. That's not counting your logic card and your communication card. And then if you need more than those 11, you can also have a second rack, and basically that rack can be connected to the communication cards of the first rack, so that those same communication cards are controlling all 22 of those modules now. So you can see that there's a lot of flexibility. You still have your relay card, as I mentioned before, so that you still get that trip protection. You can still establish your alarm limits. You can still establish what action to take when you do exceed those alarm limits, such as trip or shut down the machine. And you also have the communication card, which is used for your configuration and is also used for your Modbus communications to other external systems. Now, what about your data, being able to get to your data? Now, a lot of these protection systems, they may have localized indications, LEDs, or maybe even a display locally that you would have to go to the device itself in order to be able to see that information. Or if you're sending data through Modbus or OPC or however the data may be going to an external system, it may be going into the control room so that you could go to the control room and see some of this information. But what if that data came to you? What if you're anywhere in your plant and you've got your smartphone and all of a sudden it buzzes you saying that, hey, you've got an alarm condition on your system. So now you can look at that information on your phone right there and make some decisions about what needs to be done. So information is available from anywhere in your plant. The key thing is that the phone application and the device itself would be available on the same network infrastructure, so that this is not going to the internet. It is not putting information out in the cloud. It's all centrally located at the site itself, and it's contained within the boundaries of your IT system for security. So basically, while you are in the plant, you're able to get this information coming to your phone, to your tablet, what have you. And so again, that's live data, and it's a mobile application. And as they're showing here on this particular slide, you can have a QR that basically you can walk up to and scan. That QR basically is just your IP address, and so you scan that, it makes a connection to it, and you're able to see the status of any of those modules, any of the values coming in. You can look at the vibration data, your waveform, your spectrum. You can see all of that right there on your smart device. So you're no longer having to go to your office or go to the device or go to the control room. You get it anywhere in your particular plant. And also we talked about integration of data. So you're able to pull that information from within the system to any of your external components or external systems, PI, HMIs, any other historian. So the key thing is we use, or basically it is using OPC UA, which again is, I think this is the first generation that's had OPC UA servers embedded in the protection system. So that now whenever you're trying to get to that data, you're able to browse. Again, this is OPC UA, so this is the latest OPC offering. It is for reading data, and so it is a one-way communication. So no one is going to be able to go in and change configurations using OPC. But you're able to pull that data out by browsing that OPC server and looking for the tags, which in this case would probably be the main value tags for each of your channels that you're wanting to see. Maybe your alarm condition, if you want to pass that over, and maybe even your alarm set point. So those are valid values that one might want to pull into another system. So that is made easily accessible through the use of OPC UA. I don't know if any of you have ever tried using OPC. I have, and sometimes it's a nightmare. Effectively, a lot of people refer to OPC as Oh Please Connect because you had to use Microsoft's DCOM configuration. There was a lot of setups that if the parameters weren't set just right, they would not communicate. With OPC UA, you've got one port and you've got an IP address. That's it. It is so easy to configure that it is just really mind-boggling to those who have used OPC in the past. And also you have Modbus RTU and Modbus TCP. So that's been available for some time in most of the systems that they're able to pull that data out. Basically, you've got registers that are assigned to where your values are going to be located so that someone who wants to get that data can now map a connection to that particular register and pull that data in. So getting data out of the system is very easy. That's what the future needs to be, is to pull this data as easily as possible. It shouldn't take an IT person to be able to get the data out. So that's the key here, to make that data easily accessible as we move into things that are involving the industrial Internet of Things. And then basically availability and machinery protection, these types of systems, a lot of times people always, whenever you start talking protection systems, immediately they start thinking about turbines. Okay, API 670 is if you look at it, if you look at that guideline, they've got diagrams in the back for outfitting turbines. Here's the recommendations for sensor positions, the types of measurements to be taken on turbines, and they get also into some compressors and other types of assets as well. The key thing is most people think of protection systems mainly for turbines. So what we're here to say is that the next generation is for any type of machine. So it can be roller element bearing machines. It could be motors. It could be cooling towers, pumps. Turbines is definitely a good fit for it. Gas turbines, generators. So any of these, especially as Tom mentioned, all of the different industries that Emerson is involved in, it's applicable to any of those. Oil and gas, petrochem, power, industrial energy. So the next generation of protection systems basically it's going to be much more flexible, not only with the I/O, but it is also more applicable to other assets in the facility itself, not just your turbines or what is referred to as TSI or turbo supervisory instrumentation. So, and I believe that is about it. Yes, that's the last slide there. So, Tom, I will hand it back over to you for any questions that may have come in, and we'll see what we have out there.
All right, that sounds good. Thanks a lot, Brian, for that presentation. It's clear that this is the kind of tool that, yeah, it can cross verticals in terms of its utility and flexibility. For those who are attendees, at this point, take a look at the Ask a Question box to the left of the main slide area, and that's where to type your questions in for Brian. And we're going to move into the Q&A session right now to the end of the webcast. The first question, Brian, is a simple one about trip protection, which is that does this system still provide basic trip protection, or is this an add-on to other devices?
That's a very good question, and Tom, yes, it does still provide the basic trip protection. As we talked about, there is a logic card, so you're able to program that logic card for different scenarios, so that if that particular condition does actually exist, then it will provide a trip system. Generally, I think most people these days want to tie that trip signal into their control system, or at least into their turbine controls, so that the whole system can be shut down in a very controlled manner instead of just shutting down the asset alone. But yes, it does still provide that basic protection.
Okay. And another technical question based on the slides you wrapped up with where the data is stored. Is the predictive data stored on the device until otherwise told to either move it around, or do you have the option to back it up in the cloud?
Basically, the data is not stored on that device, but in most cases, there will be a software connection that will allow the data to be moved so that it can be stored in a database and then looked at later or post-processed by a technician or an analyst. Okay,
thanks for clarifying. Is this the kind of project where the plant manager or the maintenance engineer would want to involve IT when looking at implementing the solution, or would IT drive the conversation?
I'm sorry, repeat that one.
It's a question about stakeholder teams. When it comes to these kind of projects, and your maintenance and reliability team, is this a kind of conversation where they should involve IT in discussions from the start, or do you find that oftentimes IT may even take over some portions of the conversation?
Definitely, if you're going to have that tie-in to the software and you're going to have a database somewhere, yes, get IT involved. I have worked on projects where this is probably in 10 years or so past, where people started this discussion, started a project without IT's involvement, and then when they finally got involved, it wound up really interjecting some delays in the whole project because they weren't aware of some of the things, and of course, some of their concerns weren't covered early on. So yes, get IT involved and make them a part of that team. That they will need to be there.
Okay. We're starting to see some good questions from attendees here. On top of those, the first one is, how can I implement this kind of system in the biotechnology industry or biotechnology plant? Any specific advice along those lines?
That's a very good question. Probably we'd have to find out a few more specifics and how this could be applied. Definitely, we get that quite a bit. We have subject matter experts really about the technology, not so much about the different industries, but the more we can ask questions of what are the types of equipment, what are the types of measurements you're looking to make, and what types of sensors are being used, then that allows us to give a better assessment of how this can be applied to a particular situation. So for that particular question, I would encourage maybe contacting us to give us a little bit more information about what you're thinking, and then we can definitely give you some input.
Okay. And the same questioner asked a question about other data collectors or analyzers. The overall question is, how do you use other tools like a portable analyzer in conjunction with this system? And specifically, do you have any advice on the NIDAQ Max?
Well, basically, using other systems, whether it's a portable vibration analyzer or simply an O-scope or something else that can look at the signal, there are connections on each module, so they are buffered so that they're protected from causing any kind of trips when you plug the equipment up. And then also you're getting the raw signal. It's not processed. So you can configure your portable analyzer for the parameters that you're looking for when you collect data normally, and then you're able to plug into these SMB sockets or the SMB connections and get that data out.
Okay. Shifting gears away from the technical and more towards the financial. You mentioned the investment aspect of this, where you mentioned that essentially you're getting two types of systems in one footprint. Could you elaborate a little bit more on what you mean by that? And then sort of as a follow-up, I can continue after that one. We have a lot of our readers and attendees want to know how to build a business case for new investments like the machinery protection system. So what kind of arguments would work best on building that kind of business case?
Okay, so effectively going back to the presentation and the question, you've got two different systems. Generally, you have a protection system, and then as people are really grasping the reliability concept and trying to make their plants more reliable, you get people starting to use more prediction capability as well. So effectively, in the past, you would have to take that signal from your protection system and pass it in some way, whether it's hardwired or across a backplane or what have you, over to a prediction system. So you would wind up basically buying two separate systems in order to get the best of both worlds. Now you have the ability to get that in one system. You buy a protection system, it has prediction embedded in that device so that you're able to get these features and without having to pay twice the price or buying two systems. You're buying one system. And so now the arguments for justification really is going to come down to knowing the criticality of your equipment. So if you've never had a criticality assessment done at your plant, that's something that you may want to consider, or even consider if you have the skill set to do it yourself. But basically, you're looking at ranking all of the assets based upon how critical they are to the operation of your facility. In other words, if that asset goes down, or for a moment in time, or for a long period of time, what is the impact, the overall impact that it's going to have on your business and production and so forth? So that is how that criticality is assessed. That is how it is ranked. So you really want your critical equipment to be protected with a protection system. And in this particular system, you would wind up with protection and prediction embedded in one system to provide you a means of making or helping to improve the reliability of all of those critical assets in your plant.
You mentioned in your presentation too, Brian, that some of the other elements that go into successful implementation of a more predictive, proactive maintenance mode is that you get to manage your spares and your parts inventory more effectively. I was just curious to know, some executives may balk at the idea that, of calculating avoided costs as a real solid, hard metric. But they would respond when they realize you can save warehouse space, you save money on spares. Can you talk a little bit more about how a system like this can have a direct impact on the spares management?
Yeah, because whenever you're looking at a plant as a whole, especially plants today that have protection systems, some of the protection systems are outdated. Some have been installed 10, 15 years without much change. So when you look at those systems, again, you have modules for each specific measurement type. So you got to have a spare, at least one spare. And I think recommendations are generally like 10%. The number of modules that you have, you need 10% of that as your ready spares inventory. So now you're having to maintain these systems. You're having to maintain different modules, different cards in your inventory. And so from a management standpoint, you've got some of your cash flow tied up in product that's sitting on the shelf and not being utilized. And so with a system like this that has the flexible I/O, now you can minimize. I mean, you got a universal card, and so basically that meets just about every measurement type that you would have. So you maintain a small spares inventory of a universal card, and you can get rid of all the other cards that you no longer need. So now instead of having a specialized module for, let's say, a differential expansion measurement or for a thrust measurement or for a relative vibration measurement, you have one card. And so that can handle any of those measurement types. And so that's how you're able to minimize the number of spares that have to be kept on the shelf. And that really does get a lot of your manager's attention, because now you're talking out some real dollars that they're able to see instead of cost avoidance.
Yeah, and it's interesting, too. The plant managers that we've spoken with, everyone takes safety seriously and genuinely put safety first. It's not always as easy to attach a hard dollar cost to the benefits of improved safety, even though, the equation is that improved safety equals improved reliability. Do you find that when making a business case, it's a good idea to put in some of the metrics beyond that inventory cost to bring up the value of safety, the value of avoided downtime?
Yes, and there are other metrics that could be used at argument, but definitely being able to look at, and again, in the presentation, they were talking about the refining industry alone as to the downtime and how much time is spent in that transition and how much of the incidents occurred during that time period. But yes, you would definitely, again, that safety factor and help them understand how a more reliable plant does impact that safety measurement as well. So by purchasing or using one of these systems in their plant, then they will be able to also improve the safety as well when it comes to those transition times.
Okay. And we have an attendee writing a question here, too, about retrofits, specifically on this business case topic, where, in a situation where should we wait to replace outdated systems, or do we make a case to simply replace current systems with these newer, more proactive maintenance benefits? What's your sense of how effective arguments are in relation to should they wait to replace until the system's outdated? How easy is it to retrofit with old machines?
Well, effectively, knowing the industry, again, I've been in the industry for over 30 years, so I know the gorilla in the marketplace right now, and that particular product has been around for 15 years or better. So So that in itself, is, even if you've just installed it last year, it's still an outdated system. So definitely, I would look at when it's time to replace it, as far as um, how long it's been installed and what have you. Again, if you just installed it last year, you're not going to be able to make a good enough justification, I don't think, in replacing it again this year or next. But so yeah, you want to look at the obsolescence. You want to look at how long has it been in service, and any kind of issues that you're having, what kind of availability for repair parts and so forth. And but definitely, if you can make a strong enough argument for this type of a system, reducing the number of spares, improving improving safety, even an older protection system, if it's functioning properly, will also help improve safety. But if you can make a strong enough case, then I would begin to make this move to this newer platform, just simply because it's easy. It's easy to work with. It's easy to install. It's easy to get data out of. And so there's a lot of benefits to doing that. But it would be on a case-by-case basis as to make that decision.
Okay. And you mentioned now with the incorporation of OPC UA specifically, it's a lot easier to get the devices to talk to each other, which is another reason to upgrade to something like this, where you get the greater ease of communication. General quick on predictive maintenance. Since this is the kind of device that does foster a more proactive maintenance outlook, do you see customers pulling this in as part of their predictive maintenance strategy? That some of the basic programs are usually a mix of vibration, oil analysis, and infrared. Do you see companies who are best in class or forward-thinking pulling in devices like this say, yeah, we should have machinery protection also, more on the proactive side?
I think you're going to see more of a swing in that direction because, again, each industry, especially if you look at today's economy, each industry is challenged with their own issues. And so what we've seen throughout the last several years is, unfortunately, we've seen a reduction in force and what have you in many different industries. And, of course, we're all very much aware of the huge impact that the oil and gas industry has had on everything. So definitely, an online system can be a part of that strategy because the data is coming to, as we've talked about, data can go straight to a historian system, or it can go to the control room, or it can go to an analyst so that they're able to get that data without having to go out with their portable analyzers to collect that data. So definitely this next generation of online protection systems will definitely be a strategic part of a proactive type program that will be a key part of industry in the next generations to come.
Okay. Yeah, and I was struck by your point about transient time too, where let's go back to safety a little bit. The more we learn about failure modes and about root cause, it's interesting that some teams are able to trace so many of the failure modes and root causes back to that very specific sensitive time. It's more of an observation than a question, but do you find that most plants are aware of that stat and look to devices like this one to help get them through those periods?
Yes. Again, the different failure modes, understanding how the machine is, would fail, being able to identify, what are the specific parameters that we really need to monitor on this equipment. So all of that is again, vital to their programs, and we're seeing more and more adoption to that, even with a protection system like this that does have the embedded prediction. It's giving them information. It's giving them actionable information, actually, so that they're able to recognize what's happening with their assets, and then they can take action necessary to correct that before it does shut down the plant unexpectedly. And so this will be a key part of that particular strategy moving forward. But again, understanding that those failure modes will be a key part to that as well.
And I was curious too, are there specific failure modes that you know that normally stand out when you're setting up these trips that are common between plants, or is it site-specific, as you said, like earthquake modes in California versus other kinds of regional considerations?
Well, in most of your protection systems, your trip set point is going to be based on an overall vibration level. So really, it's not, they're really not even digging into the failure modes. They're just saying, okay, if my overall vibration reaches a certain level, then I want to trip. Now, with prediction, you're able to look at different parameter bands, if you will, so that you can set those parameters around particular areas of interest. So like we mentioned, some of the defects, misalignment, imbalance, looseness, things like that. So now you can track that, and you can get an alarming based on those particular parameters. So now you understand more about the failure modes, what is affecting this machine, and then you're able to set that up so that it alarms you and alerts you to a developing condition long before it shuts you down automatically because of a trip set point on an overall vibration level.
Okay. And last question, we're close to time. It's a question about the mobile aspect too. You mentioned the alerts. Do you find that these days plants are accepting of people bringing in their own devices to get it synced up with a system like this, or is this the kind of thing where you'd see plants hand out the devices themselves and have that run through IT, or a little bit of both?
A little bit of both. That's one of the IT nightmares is bring your device to work. So one for security and other things, but that's a totally separate issue that IT has to deal with. So you've got some companies that are providing the devices. Some do allow BYOD so that you can bring your own in, and then we're seeing, surprisingly, we're seeing a good acceptance, wide acceptance of the phone applications, mainly because, as I said, this is all site-centric. It's not going to the internet. It's not going to the cloud. So security is available. It's very secure. And then also the communications is one way only. It goes out. They cannot come back in with any information or can't change the configuration. So we're getting wide acceptance with that. And I just believe that the whole wireless environment in general is just going to continue to improve when it comes to security because it's such a widely used technology.
Okay. Yeah, and I hear you when you're talking about the single direction communication. That's often the one of the red flags which IT will note when it's a lot easier to sell technologies when it's just one directional communication so that nothing can come back in, like you said, from any other device. Yeah. Well, all right. We're very close to time here. So at this point, Brian, I want to thank you for being with us today and speaking on this topic. I also want to thank our sponsor, Emerson Process Management, and thank all the attendees who joined us today. Within 24 hours, we'll let everyone know when this webinar will be available for on-demand viewing. The handouts from today's presentation also will be available for on-demand viewers. It will remain posted online. This includes an interactive presentation on machine health monitoring, an overview of Emerson's CSI 6500 machinery protection solution, and the full set of speaker slides. We also encourage you to visit plantservices.com and access to even more tools and resources aimed at helping you achieve success. Did you like this presentation? Let us know your thoughts by answering our brief survey that will appear on your screen shortly. Your candid answers are genuinely appreciated and help us craft future events. Once again, thank you, Brian, for being here, and everyone on the call, have a great rest of the day.